The Microsphere microreactor technology is mainly consists of two parts. The first part is producing some spherical particle from either biomass or plastic with size of about 100 until 700 in diameter. And in the second part, we have designed a microreactor fast pyrolysis on a single microsphere particle. And we should be able to measure the velocity of particle, biofield residence time, and amount of hydrocarbon which comes from pyrolysis after only 1 millisecond. And finally, exiting the char from the reactor. This is a picture of microreactor for the fast pyrolysis. This reactor is include a quartz microtube with 1 millimeter diameter and a small igniter to pyrolyze the particle rapidly. The distance between designated temperature and cold place is only 3 centimeter. This system is fixed on an optical table bench plate using a standard optical fixture vertically. And to explain how this system works and why we designed it this way, I need to explain what this system will do for us. We need to move a single microsphere particle through a quartz capillary reactor with a constant velocity and stop it in a designated temperature very fast. So we should be able to detect the position of the particle during this process. And in order to reach constant velocity, this system needs to position vertically, and it should be a distance between the starting point of the carrier particle with the hot zone, which is about 70 centimeters, to make sure flow is laminar and it is fully developed. Now I'm going to explain the experimental precision. We have ultra-high pure nitrogen cylinder gas as a carrier gas, which is connected to a flow controller, and flow controller is connected to an electrical TV valve. First, we inject a particle into the system, and then we connect a carrier gas line. And we set the flow controller in the low flow rate, such as 10 SCCM, for purging by a pure nitrogen about 10 minutes. And after purging, we should close the electrical valve and increase the flow rate. And when the valve is closed, the carrier gas going through the system in the another direction in order to establish hydrodynamic steady state. And there are two fast response pressure transducers to monitor the steady state behavior pressure. When we open the electrical valve, the gas no longer goes into the purging direction, and gas carries the particle into the furnace. As the particle moves through the quartz microtube, it passes across three last lasers which collect the velocity of the particle. And we stop the particle by an inert probe plug. There is a laser detector right in the trap position of the particle to monitor the time that particle reaches to the inert probe plug, and we don't want to lose any information about the product gas. We monitor the gas using the fast film ionization detector with 1 millisecond response time. And here you can see the raw data from fast ionization detector, and we use high speed data acquisition and wrote a program to collect all of the data at the